time to dive a little deeper into the normal distribution. Now, as I alluded to in the last lecture, many numerical variables naturally follow a normal distribution, or a bell curve. Now, normal distributions are symmetrical around the mean and have no skew, meaning that the mean is typically equal to the median, with most of the data concentrated around its center and flaring out in tails on both ends. For example, let's take a look at all the Olympic basketball player heights in history. You can see that the data, or the frequency distribution here, is symmetrical around the mean, with most of the data near the center of the distribution, and then fading away towards the sides. And you can see this in human heights, in human weights, in IQ scores, in blood pressure, and many other variables. And since these distributions are so common, many statistical tests are designed for normally distributed populations, which is why we'll mostly focus on the normal distribution in this course. Now, the normal distribution is described by two values that we already know how to calculate and interpret: the mean and the standard deviation. And we can actually see that here, this is the probability density function for the normal distribution, which determines the height of the normal curve at any value x, given a mean, which is represented by this symbol, which is called mu, and a standard deviation, or sigma. And before this scares you, because it is scary looking, we won't actually use this formula as you're seeing it right now, don't worry, because there's an Excel function for it that we're going to use instead. But my point though is that if we assume that Olympic basketball player heights are distributed normally, which seems like a reasonable assumption given this distribution here, then we can take their mean and their standard deviation, pass it through this formula, and we get this line or normal curve, which as you can tell fits the data pretty well. And this line is now a model that we can use to calculate probabilities of Olympic basketball player heights. Now, these two values also describe the properties of the normal distribution. The mean determines its center, which makes sense since it's a measure of central tendency, and the standard deviation determines its width, which also makes sense since it's a measure of variability or spread around the center. So if we grab this normal curve here that has a mean of 180 and a standard deviation of 8, and then change its mean to 160, well then the center will shift to 160 and the width will stay the same, which also applies if we change the mean to 200 instead. Now, if I stick with a mean of 180 but change the standard deviation, you'll see that if I make it smaller, then the curve gets narrower and taller, and if I make it bigger, then the curve gets wider and flatter. In other words, changing the mean shifts the curve along the x-axis, and changing the standard deviation squeezes or stretches the curve. So that's the normal distribution. Now let's quickly move over to Excel and see an example of this with our project data. Again, I am in the Excel statistics workbook, but now we're going to go to the links under the probability distribution section, starting with the first one on the normal distribution. And what we want to figure out now is if the final grade distribution for the graduates follows a bell shape. And in one of the assignments in the previous section, we had already created a histogram with the distribution of MBA grades. That's why I added that here already. So now let's just take a closer look at it and see if it follows a normal distribution. And it does look like it kind of follows the bell shape here, and it is relatively symmetrical. So let's see now if the mean is equal to the median. In other words, is the average value also the middle value? So let's calculate both of these, get the average of our data and the median of our data. You'll see that they are the same. We get 80.17 and 80.20, which is right around here, which is the center of my distribution. So it does look like all signs point to these grades being normally distributed, and it's actually not crazy to think so because grades do generally follow normal distributions. A classic example of this being SAT scores. So you can look it up online and you'll find that they very closely resemble a bell curve. So now all we need is to describe this normal distribution using the mean and the standard deviation. So we know the mean already. It's equal to this. And we know how to calculate the standard deviation. Close this. And there we go. So this right here is our normal distribution of MBA grades.